Let's talk forensics with Pastor Dan. We're starting a new concept. That concept is called blood analysis. Now, blood analysis is defined as the means of determining the relationship of a suspect to a crime based on the blood or how blood is found. This area of forensics is referred to as serology. So if you hear somebody talk about serology, that is blood analysis. Now, the history, when we first began to look at it, the first year is in 1901, and that's when we begin to identify the concept of blood typing. Before that, they tried to give transfusion. People would die. They didn't know why. It's because those factors, those blood types, and if they don't match up, you can get sick, you can die, have problems along those lines. Second major event took place in 1937. In 1937, the RH factor. RH factor is called rhesus factor. It was originally found in rhesus monkeys, and that's where that came from. And so that is what we're looking at that way. And then the really big one, the early 1990s, we're not going to talk about it at this point. We'll look at a separate section onto itself, looking at DNA, deoxyribonucleic acid, that big one that blew apart the field of forensics. Now, when it comes to blood analysis, blood typing is the first one we did, and it's a major way of identifying different parts of the population. Blood typing is defined as antigens which are specific characteristics in red blood cells. Inside of your hemoglobin, the red blood cells, those are either A or B. And if you don't have A or B, you have what's called O. And then you have the other one is AB. Now, what does O mean? That means there is no antigen. So if you have O blood, there is nothing in the blood. It is pure, clean, no antigen together. AB has both of those together as in the type. So what part of the population exists that way? Well, the process of identifying, I'm sorry, I'll get ahead of myself. When we test for the different types, we put an antigen, an antibody to each of these types. And when they're there, they glutinate. Now, it sounds like a coagulate, but it's a different process. Glutination is when a rice-like material is formed. So if you put in there and you see this white, like little strands in there, that's glutination. That's how we identify that antigen, either A or B, is present. Now, the population, how does it work out? O blood is 43% of the population. A is 42% of the population. B is 12%. And AB is rare. It's 0.13% of the population. Sorry, just 3% of the population. Now, that RH factor. Actually, the scientists called it antigen D, but they didn't want to do AD, BD, causing confusion. So they just identify as being RH positive if it's there, and RH negative if it's not there. Now, this is something that takes place if women become pregnant, they have to test for. If the woman who is pregnant is RH negative and the husband is RH positive, there's a 50-50 chance the child could be RH positive. And if that RH positive is in the body, the body actually will begin to attack it and go after it. And that's why a lot of miscarriages would take place early inside of, before we knew about this. So what they'll do is they'll test for it and they'll put a suppressor in the body so that the body won't go after it and try to harm the child. All right, now, population for RH. RH positive is 85% of the population, and RH negative is 0.15. Now, there is one other thing that we can also look at, and that's additional proteins. There are 3 additional proteins that do exist. They're called MM, MN, and NN. So we can get into those as well to even further limit the population down as far as who is present. Now, the population there, MM is 30% of the population, MN is 48% of the population, and NN is 22% of the population. So what can we do with this? Well, let's say I have something that's AB negative NN. All right, so we said that AB was 30%, so that's 0.03, moving two places to the right. We said that negative was 15, so that's 0.15, and NN was 22%, so that's 0.22. So take your calculator, multiply 0.03 times 0.15 times 0.22, and we get 0.00099. We're going to move the decimal places to the right to get a percentage. So let's say it's going to be 0.099% of the population, or basically 0.1% of the population. All right, let's try O negative MM. So here what we're going to do, O, we said was 43% of the population, so that's 0.43. Negative, again, is 0.15, so that's 0.15. And then MM, we said was 30%, that's 0.3. Let's put a little point in there. All right, so we multiply that through, we get 0.01935. To the right, we're going to get 2% of the population. All right, try this one on your own. A positive MN. Go back and look at the percentages. See if you can calculate it through on your own. See what you get. Pause it if you need more time. Ready? Here we go. So we get 17% of the population. Now, if we want to determine how much, we would take that decimal number, this 0.02 here for 2%, and multiply how many there, and that's how many suspects we have to look through. All right, that's it. Hopefully that's not too bad. Take care. God bless. Bye.